Hello, my name is Brandon and welcome back to Kerbal Space Program. So in today's episode we're going to go back into our saved world and let's play. And we are going to use all of the new parts that we got to do science in orbit. So just to review our tech tree, we researched these additional parts, namely the small liquid fuel engine for lander, a landing strut, and another parachute that will be very nice to have. All of these upgrades require more science than we have, and I'm going to hold on to the science because nose cones, radial decouplers, and winglets just aren't what we need right now. So let's head into the vehicle assembly building here and build our next rocket. So we'll go with the tried and true command pod and pull out the parachute. And before we get carried away, we will add a communicatron so that we can send data home. And we'll add some mystery goo pods, see if they behave differently in orbit. We'll go ahead and just add 4 of those guys. Hopefully that doesn't obstruct our Kerbal from getting out. Actually, let's just go with 3. And so now we add our decoupler and proceed to build the rest of the rocket underneath. Also today we're going to pioneer something we really haven't done yet, and that is liquid fuel. So we will put 2 of these fuel tanks on, and then we will, actually let's do 1 of the fuel tanks. Drop that over there and put the small engine up top. That way we have a really small, really efficient little spacecraft there that we will boost to altitude with, some solid rocket boosters. And, whoops, we'll just put this guy down there for a ridiculously tall rocket that hopefully will not just reach space, but also reach orbit. And we'll call this Solid 2 Liquid 1. So we will save. Oh, and I completely forgot. We researched. We did not yet research. Never mind. And we will launch. So we've got Jebadiah once again. We'll throttle up, turn on our SAS, and 3, 2, 1, liftoff. Now this is a pretty slow liftoff because these long solid rocket boosters have a fair bit of mass to them. They also burn longer and they burn harder than the shorter solid rocket boosters. So we should get good performance out of this guy. Oh, you can see the little shadow as we go up. And that's a nice view. So as we're on ascent, we watch as things get smaller. There's actually videos of Delta II rockets and Delta V's that are shot from the upper stage. The Falcon 9 has it as well, where you get to see the Earth getting smaller beneath you, which is really a neat thing. So let's go ahead and stage. And this is going to give us the same thrust we had before, but since we now have a vehicle that's a lot less massive, because force equals mass times acceleration, the force is the same, the mass is a lot less, so that means the acceleration has to go up. And so that's why we are clearing 250 meters per second, and we're almost up to 10,000 meters. The beauty of 10,000 meters and 400-ish meters per second is that's when we start doing what's called a gravity turn. Now, for orbital flight, it's not enough to just go up. You also have to go sideways. And achieving that orbital motion is done with what is called a gravity turn. Looking at this rocket, I'm not sure we're going to make it to orbit because we've wasted a lot of our initial Delta V. We'll go ahead and stage. A lot of our initial Delta V was wasted going too fast in the lower atmosphere. So we'll continue on up. Our current apoapsis is 47,000 meters. So we'll just throttle up and thrust mostly sideways to build up some more speed sideways, so that instead of just going up, which we can look at this from a Kerbal-centric, we're going up, but we also need to go sideways to have an orbit. The Kerbal atmosphere goes up to about 68,000 meters, so we need to go up and up over 68,000 meters and then continue sideways. Which, given the amount of liquid fuel we have and our current velocity, I think we might be making it to orbit today. We're definitely making it to space. So we'll go ahead and observe the mystery goo. And we'll save that report. And let's see if we can get a crew report out of these guys. The crew report from Kerbal's upper atmosphere is boring. So we'll just transmit that down to the ground, get a little bit more science. And this little engine isn't going to recharge us. So the amount of time we're going to be able to spend in orbit will be limited. So you can see we're going up still, 68,000 coming up on, or 67,000 coming up on 68,000. And our apoapsis, our highest point, is flanked by a fairly wide trajectory that we're trying to stretch into a circle. As soon as we cross that 68,000 foot barrier, we will observe the next mystery goo and make sure we have enough propellant and electrical charge to return back to Kerbal. Or what we can do is, if we are pointed along this, we'll just wait until this turns into a retroburn, because the spacecraft will hold its attitude around Kerbal all by itself. And I think we are very close. Yep, you can see our periapsis. As soon as that gets above 68,000, we will be in orbit. Close enough. So we have an orbital flight. Oh, and we're almost out of gas. That's not good. We might strand our poor Jebadiah. But now that we're up here, let's go ahead and expose our last mystery goo, or observe it, see what it says. It's clumped into a sphere, and it's brittle. We've seen that before, so the scientific value of that has gone down considerably. This mission actually reminds me of Scott Carpenter, who was one of the original Mercury 7 astronauts. He flew the orbital mission after John Glenn. He flew 3 orbits of the Earth, but there was a problem with his automatic flight system, that he ran out of maneuvering fuel. And in running out of maneuvering fuel, he, how shall we say, he had a little problem. He wasn't exactly lined up for re-entry, so when he did his retroburn, which we're going to have to do a retroburn to come down from orbit, retro being against the motion. Anyway, when he did his retroburn, he did it, and he wasn't quite pointed where he thought he was, so it ended up pushing him off course, or he didn't go on course, and so they actually spent a lot of time looking for him, and they had a hard time finding him. So, since we're in orbit, I'm going to add at the apoapsis a retroburn, hopefully one that we can make, and again, with any luck, we will be able to get to our apoapsis, make a retroburn with what little fuel we have left, because that's just like a pixel of fuel, almost none if you look in our resources. Hopefully that is enough to bring us on back. So we will fast forward time and get to our highest point. And once we get out to apoapsis, which you can see we're humming along pretty good, nice and high, we will slow down time and make our burn, and hopefully, Jebadiah will be coming home from space today. So, we've got 4 seconds that we have to burn to get what we want, and we're almost to apoapsis, close enough. So, we will do our retro burn, and we are safely coming back. And we're out of gas. So let's go ahead and discard this stage. And, oh, we still have one more mystery goo to observe, so we'll go ahead and observe him. And it feels right at home. Oh, good, we've got new data. Also, we can put Jebadiah out on EVA, and we don't have to drift away. We can do an EVA report, get a little bit more science. Yeah, we'll go ahead and keep that, and we'll board back up to the spacecraft. And now, all we have to do is wait for Jebadiah to cross this cover this last length, and he'll literally fall back to the surface of the Earth because there's no more thrust on him. So let's go ahead and point down the picturesque sunrise. Screenshot. And we'll fast forward and turn off our SAS. And we're going to be coming in. And we're back on the atmosphere, so time is now at its normal 1x, and we're spinning pretty good. And oh, we do have enough battery to go ahead and fix our re-entry attitude down to pointing directly in the direction we're going. In Kerbal Space Program, if we come off of this guy, the little X here means that we are pointed in the retrograde direction, or we're pointed against our velocity vector. If we flip around, the circle tells us, there's the circle, this circle right here tells us what our velocity vector is. Oh, and since we are coming in close to the place where the atmosphere is pushing against us, we're getting nice little re-entry effects. Now would not be a time to go on EVA, because if we went on EVA, that would be bad news for Jeb. So hopefully, oh, we're not going to be splashing down. We're going to be landing on the mountains, which is not good, because we have 3 of these goo pods, which might mean that we might have some spacecraft damage when we land, and there might also be some tumbling like there was last time. So we let the re-entry happen. Jebadiah seems happy, and we are out of electric charge, which means we're going to start tumbling in just a second. Interesting thing about the electric charge, the vehicle has reaction wheels which impart torque on the vehicle, and that torque requires electric charge. In real spacecraft, when you have reaction wheels imparting torque, they only impart so much before they saturate, and you can only spin a wheel so fast before friction in the wheel starts messing things up. So you have to use thrusters to fight against your reaction wheels so that the reaction wheels still have what's called torque authority. Most reaction wheels spin, 6,000 revolutions per minute or so. The big ones can spin slower, but yeah. So anyway, we've got a spacecraft that has been totally used up. Sorry about that. And we are coming down. Looks like we have a nice flat spot to land. Oh, look at those mountains. Update 0.20 really improved a lot of the terrain on the planet Kerbin, and it looks really pretty. Now, you might have just heard that big fluff. The way they do that with the parachutes in the real space program is they actually have razor blades that cut, and that cutting process to make it so that the parachute expands fully is called unreefing. And some parachutes have 2 stages of unreefing. Some have 1, but all of them do that because most of them are deployed either in the high subsonic realm or supersonic realm. And if you deployed it all at once, you would have major issue with drag just ripping the chute apart. But as you can see, we are getting close to the ground. We've got a surface speed of 8 meters per second, which means we might have problems. Excellent. We have a soft touchdown. Let's have Jebadiah pop out and take a sample of this piece of Kerbin. Take a surface sample. 9 scientific value. I think that's the same one we got last time. We'll do an EVA report. The spacesuit is still not necessary for this guy. So we'll get back on the spacecraft and board, and we'll go ahead and recover the vessel and see how much science we got. Alright, we've got 58 more science this mission, so we've got a total of 76 science. I think everything that we could possibly want to get was 45 science. So let's go ahead and head to the Research and Development building and look at what we can research and what we will research. So here, for 45 science, we can get a radial mount liquid engine and a fuel tank, which are all respectable. Ooh, struts. Struts are very important. And the radial decoupler, also very important. The launch stability enhancer helps keep big rockets stable. We're not going to be doing big rockets just yet, so we really don't need that one. This one, we've got winglet, which is helpful to keep things pointed straight. Ooh, another cockpit. An unmanned probe, and an inline reaction wheel, which we spoke of reaction wheels just a little bit ago. None of those are terribly important. However, this guy, batteries, science, and another kind of science, and then another kind of comm, that's going to be helpful in getting more science. So we'll take the science heavy route. We'll research this guy. And now we have 31 science left. We won't be able to research any of these because these are all really expensive. They're 90 science each. So I think that does it for this episode. My name is Brandon. Thank you so much for watching. If you enjoyed, leave a like, and remember to keep everything in the middle of the nominal tolerance band, and that safe mode is your friend.